So today's lecture is on carbon footprint analysis. So this is a hot topic this year because last year and this year there are many incidents happened. We have some natural disasters like the wildfire in Australia and in Amazon, and also we have the heat waves in Europe, and we all notice that the air temperature is getting higher and higher, and we have the flooding in Venice, and we have the virus going. The outbreak of the virus, different kind of virus. So all these are actually contributed from the climate change. Okay, so on this slide we have a few evidence of climate change. Okay, like global warming. Okay, so every year is getting hotter and hotter. So without any data, okay, we don't need any data actually. We can actually feel the temperature is getting higher every year. Okay, diminishing glacier, the Arctic sea ice decline. So we can read these from the news. And the severe weather, the acidified oceans, rise of sea level. So Hong Kong is near the shore. So if the sea level rise, it will affect the living habitats of many people in Hong Kong. Okay, so not just Venice, not just in other places. So actually it happened in Hong Kong. The sea level is getting higher and higher, and it is affecting the habitats of all of us. Abnormal precipitation. So last year we have many typhoons, and the rainfall is high. The rainfall was high, particularly high, and so it's quite strange because the temperature is high, but we also have high rainfall. So usually when it rains, the temperature will get lower, but last year is humid, is hot, and the rainfall is also high. Okay, wildfires. So in Australia, in Amazon, so we have a long months. The fire was not able to be put out for months, and the fire is burning away the trees. So the trees, so the Amazon is named as the lungs of the earth. So without the trees, we don't have, so trees convert carbon dioxide into oxygen. So the fire burn away the trees. So at the same time, the fire gives out carbon dioxide, and it also reduces the functions of the forest to convert carbon dioxide into oxygen. So more and more carbon dioxide is released into the atmosphere. Okay, heat waves, flood, droughts, storm, infectious disease, air pollution. So all these are happening. So climate change is already a fact. So it is not a belief, it is not a prediction, it is already a fact. So this is happening. And we all visualize these changes to our lives in this year. Okay. So some quote, the saddest fact of climate change is that the countries it will hit hardest are already among the poorest and the most long suffering. Okay, so Hong Kong is not a rich city, but we are not poor. So I always think that we are already lucky to be live in this city. So you can imagine if you are living in, I don't know, some other places with which highly depends on the local aggregation, or or maybe subject to maybe the natural disaster could hit hard in those cities. So it really affects the lives of people there, and so for Hong Kong, we are lucky to stay away from the earthquake, the flooding, and the drought, and we are near the sea. So although the temperature is getting higher, but still we have the wind from the sea. So we are already lucky in this kind of climate change. Okay, global warming, along with the cutting and burning of forests and other critical habitats, is causing the loss of living species at a level comparable to the extinction event that wiped out the dinosaurs 65 million years ago. That event was believed to have been caused by a giant asteroid. This time, it is not an asteroid colliding with the Earth and wrecking off. It is us. So it is us which lead to the extinction of many, many species. So maybe you may not be aware of the extinction of other species, because those extinction is the small animals, small insects. Okay, but they are small, but it doesn't mean that they are not important. Okay, so life is we have a very long food chain. So other animals will be the food of some other animals, and then ultimately it will affect the food of the human. Okay, so it is the whole ecology of the earth, and each species will be related, will be important to the other, to another, and we cannot just stay away from this kind of climate change. We are inside, so we all need to do something and try our best to save the earth. Climate change is occurring. It is caused largely by human activities and poses significant risk for, and in many cases, it is already affecting a broad range of human and natural systems. Okay, so in this figure, it shows the statistics of the CO2 concentration. Okay, so we are now, okay, here. Okay, and within this short period of time, okay, so this is a long time ago, so too long ago, so we are now here. So if we zoom in, okay, if we zoom into this small period of time, so we are here, and the concentration, so some 100 years ago, the concentration of CO2 is only around 250 ppm, okay, and now it's getting higher and higher, dramatically, almost 400. Okay, so, and we know that carbon dioxide is the contributor to the global warming. Okay, so just within this short period of time, the concentration of carbon dioxide has been increased for over 100 ppm. So mining and burning of coal. So coal, natural gas, these are fossil fuel. Okay, petroleum, these are fossil fuels. So burning these fossil fuels and mining. So they are the largest sources of the man-made. So anthropogenic. So this is man-made greenhouse gas emissions. So burning the fossil fuels is the major contributor to the greenhouse gas emission. Okay, some more picture to show you, which is the evidence of the global warming. So these 4 pictures were taken on the same date but different year. Is it the same date? Not really, but same season. Okay, and we can notice the amount of glacier is getting less and less and less. And this is the simulation or computer-generated picture showing the Arctic sea ice. And once again, okay, so they are the simulation on the same date but different year. So the upper picture was 40 years ago, and then the lower picture is in the year 2012. So we can see the amount of ice is getting less. So it is an obvious observation. Total temperature increased by how much? 1.2 degree since the pre-industrial times. So before 1900, 1900, before the year 1900, we have a not too high air temperature. We have a stable air temperature, but after the industrial revolution, the air temperature is getting higher and higher. Okay, so this is after the 19th century. So this is the global average. The global average temperature increased by 1.2 degrees C within this 100 years. So how about in Hong Kong? Over the past 50 years, data on extreme temperatures have shown similar trends of rising temperatures. Cold days and cold nights and frost occurred less frequently over time. So cold days. So in blue color, annual number of cold days. So cold days means the minimum temperature is below 12 degrees. So we are getting less and less and less cold days and night, while the hot days, hot nights, and heat waves occurred more frequently. So for the yellow color, this is the hot nights, and the red color is the very hot day. So we have more and more hot days and hot nights. So it only shows the it shows the trends. So maybe you will ask, next year, we don't know what would happen next year. So why they can do this kind of simulation? So they are predictions, and they will probably be true because the carbon dioxide is already in the atmosphere, and the lifetime of the carbon dioxide in the atmosphere would be 100 years or 1,000 years. So even if we don't produce any carbon dioxide today, the atmosphere already contains a large amount of carbon dioxide. So what I mean is that these prediction would be probably true, and so there are many new technology about how to solve this problem. Like there are some invention which can capture the carbon dioxide in the atmosphere. So these are some new invention which may be able to reduce or not reduce. Okay, maybe it can lower the concentration of the carbon dioxide. And at the same time, we all need to try our best to lower the man-made carbon dioxide emission. The increased rate of Hong Kong annual mean temperature has rose from 0.12 degree per decade to 0.2 degree per decade. Okay, so the air temperature, so not only in average, in globally, so in Hong Kong, so locally in Hong Kong, we are also experiencing the rise of air temperature, and the rate of the rise is getting higher. Okay, so some years ago, we have 0.12 degree of air temperature rise per decade, but now 0.2 degree per decade. So maybe next year or next decade, we have 1 degree of air temperature rise per decade. So getting higher and higher. So under the high greenhouse gas concentration scenario, the temperature is expected to rise from 1.5 to 3 degree and 3 to 6 degree in the middle of the 21st century. Okay, so by the year 2060, so how old will you be? So maybe around 60 years old. So our life is getting longer and longer. So I believe that you will be alive by that time. So you will be able to experience or to visual these kind of climate, the rise of air temperature. So in the year 2060, so the air temperature will rise by maybe 2.5 degree or maybe up to 3.5 degrees. So these lines represent different kind of predictions. So this is the worst case, high concentration scenario. So if the carbon dioxide is on the high side of our predictions, then by the year 2060, the air temperature will be higher than, will rise by 3.5 degree. So in Hong Kong, in the summer, the air temperature could be up to 35, 36. So a rise of 3.5 degree would be very much. So maybe in the year 2060, when you are 60 years old, the air temperature in the summer in Hong Kong could be up to 40 degrees C. And 40 degrees C is a very high temperature. So our body temperature is 37. So in the environment of 40 degrees C, you need to put on clothes because the outside air temperature is higher than your body temperature. So you will want to reduce the heat transfer from outside to your body. So instead of wearing short sleeves, maybe by that time you need to wear more clothes to reduce the heat transfer, or maybe at I don't know. So this is some predictions. So we are now where we are now here. Okay, so we still have chance to revert this kind of predictions. So okay, so maybe you can see this graph as maybe too pessimistic, but this is the prediction and this is science. So although although the prediction, although the data shows that the temperature will get higher and higher and life is getting more difficult, but still we need to do our best to reduce the carbon dioxide emissions. Okay, so before we study the carbon footprint, so maybe we should talk about the greenhouse effect. So the greenhouse effect is the reason of global warming. So greenhouse effect is a natural warming process. Carbon dioxide and certain other gases create a warming effect that has some similarity to the warming inside a house, a greenhouse. So actually we need greenhouse effect. So greenhouse effect is not a bad thing. So if we don't have greenhouse effect, then at night, when we don't have the sunlight, the earth will be very, very cold, below the freezing point, well below the freezing point. Okay, so we need the atmosphere. We need the water vapor, the gas in the atmosphere, so that it can trap the heat in the daytime, and so that in the nighttime we still have the heat and the air temperature will be suitable for the living of human. So the natural greenhouse effect is important to all living things on Earth. But now we have the man-made greenhouse effect, and it is due to the release of the carbon dioxide by burning the fossil fuel. Okay, so let's explain what is greenhouse effect. So when sunlight reaches the Earth's surface, it be reflected or absorbed. So the absorbed sunlight warms the surface and it is released back to the atmosphere as heat. So greenhouse gases trap this heat in the atmosphere and warming the Earth's surface. So in the atmosphere, we have the water vapor, we have carbon dioxide, we have the methane, we have the nitrous oxide. So all these will absorb the heat from the sunlight in the daytime. And then it will release this heat in the nighttime so that at night it will still be warm for people, for human to live. Okay, so the greenhouse gases include the water vapor, carbon dioxide, methane, nitrous oxide. So the natural occurrence of the greenhouse gases resulted in a natural greenhouse effect. So without the natural greenhouse effect, the Earth's surface would be well below freezing. So what are the process of the natural greenhouse gases production? We have the water vapor in the atmosphere, and when we breathe, we produce the carbon dioxide. But at the same time, so not only human, so any animals breathe will take in oxygen and produce carbon dioxide. And we have the trees, right? We have the trees which need the carbon dioxide and they will give out the oxygen. So actually in the nature, there is a balance between the production of the carbon dioxide and the take-in of the carbon dioxide. But now human is producing more and more carbon dioxide. So natural greenhouse effect and the enhanced man-made greenhouse effect. Okay, so for the enhanced greenhouse effect, increasing the amount of greenhouse gases intensify the greenhouse effect. The side of the globe simulates conditions today. Okay, so on the right-hand side, this is for today. And roughly 2 centuries after the Industrial Revolution began. Okay. And on the left-hand side, this is the natural greenhouse effect. We have the carbon dioxide and other kind of gases, and it creates a warming effect. Okay, so the enhanced greenhouse effect is due to the higher and higher concentration of carbon dioxide, and not only carbon dioxide, and the nitrous oxide, and also the methane and some other, and it trapped more and more heat. So it lost the balance. The Earth lost the balance between the in of the carbon dioxide and the release of the carbon dioxide. So let's study the greenhouse gases. So humans are currently adding to the naturally occurring greenhouse gases in the atmosphere, causing more warming than occurs naturally. So this increased the radiative forcing from human activity is contributable mainly to increased atmospheric carbon dioxide levels. So the radiative forcing, it means the heat trapping ability of the atmosphere. Okay, so sunlight is a kind of radiation. So the radiation from the sunlight will be absorbed by the greenhouse gases and then released to the atmosphere after some time. Okay, so this is the radiative forcing of the greenhouse gases, and this radiative forcing is increased because of the human activity. And the human activity increased the carbon dioxide concentration. Okay, so what human activity would increase the carbon dioxide concentration? We have deforestation. So we cut down the trees. So the trees are used to, or the trees would convert the carbon dioxide into oxygen. But now we cut them down, maybe for building houses, maybe for making paper, maybe for making furniture. So we cut down the trees, and we lost the thing that can convert the carbon dioxide into oxygen. And we burn the fossil fuels, okay, the coal, the natural gas, the petroleum. So all these are fossil fuels. And burning anything would result in carbon dioxide. Burning biomass will also result in carbon dioxide. So biomass is a kind of, is treated as a renewable energy. Okay, so biomass will be the wood, maybe burning the waste from the animals, burning the dead bodies of the animals. So these are biomass. So the organic so you may burn the organic thing for maybe for cooking, maybe so just like in some countries, in some poor countries, they will burn the woods for cooking. So burning wood is biomass, burning biomass. So burning anything will result in the carbon dioxide. And methane is another kind of greenhouse gases. So burning of natural gas will result in methane, and the landfills. So in the landfills, the microorganism decompose, so it will also generate methane. And the livestock, the cow, okay, so the cow is a big contributor to methane, because in the digestion process of the cow, they will produce the methane. So you may have heard that the green organization will persuade you to eat less beef. It's because when the cow digests food, it will produce much methane. So if you eat less beef and there are less cow on the earth, then the concentration or the production of methane will also be reduced. Nitrous oxide. So nitrous oxide, another kind of greenhouse gas, and it will be result from the fertilized agricultural soils, the manure of the livestock, the runoff, and the leaching of fertilizer. So nitrous oxide is related to the agriculture, okay, planting and making and the planting of the food, the vegetables. So we human need food. So we need the agriculture. We need we need to plant vegetables, and the vegetables to feed the livestock. So as long as we human need food, then there will be nitrous oxide produced from these activities. And some other, like the SF6, is produced. It is used for electricity transmission. So in the transformer, we have the SF6, and CFCs is used as refrigerant in the air conditioning system. So in our air conditionings, we have the refrigerants running through the pipe, and CFC is used or was used, but is now not recommended to be used because of its contribution to the ozone depletion. And HFCs, it is also used as the refrigerant in the air conditioning system, and they were used to replace the CFCs as they are less harmful to the ozone. But it also contributes to the global warming. So these are the greenhouse gases, and so in our daily activities, okay, when we take the bus, when we take the ferry, and in the electricity generation, in the electricity transmission, and in the office, in the buildings, when we just at the moment when you turn on the light, when you turn on the water tap, we are already producing the carbon dioxide and contributing to the greenhouse effect. Okay, and the agriculture. Okay, the three main contributors to the greenhouse effect would be the carbon dioxide, the methane, and the nitrous oxide. So this table summarizes the source and the sink. So the sink would be how can we store up these greenhouse gases. So like for the carbon dioxide, it will be produced by burning the fossil fuels and by cutting down the trees. So less the carbon dioxide is getting more and more, and we may have the ocean to take up the carbon dioxide, and we have the plants to take up the carbon dioxide. And for the methane, we burn the biomass and the fermentation and the rice. So methane is produced from the microorganism. Okay, so in this kind of fermentation process, it will produce the methane. And for the sink, the methane can react with OH, and the microorganism in the soil can also uptake the methane. So nitrous oxide burning, so once again, burning, and the fossil fuel, burning fossil fuels and the fertilizers, removal. And for the sink, the nitrous oxide can be removed by the soil, and the stratospheric photolysis of the reaction with the oxygen. Okay, and importance to the climate. Carbon dioxide absorbs infrared radiation, so absorb, but it will also radiate the infrared into the atmosphere, and it affects the stratospheric, means the atmosphere, the ozone concentration in the atmosphere. And so carbon dioxide, methane, nitrous oxide, these are greenhouse gases, and it will contribute to the global warming. Okay, this is an interesting website. So you may go to this link to view the changing of the global cumulative carbon dioxide emission. So this figure shows the share, the percentage of the carbon dioxide emission in the whole world. So in the year 1800, UK was the first industrial scale carbon dioxide emitter. So the UK was the country or was the origin of the Industrial Revolution. So we have many great machines being invented in UK. So in this early year, so how many? 200 years ago, UK is the main contributor to the carbon dioxide emission. And then 100 years later, the emissions in other European countries and North America shortly followed and produced carbon dioxide over the majority of this time period. So 100 years ago, we have the Europe, United States, and also Canada producing the carbon dioxide. And for the rest of the world, nearly zero. Okay, so the main contributor would be from these countries. And then recently, other regions like the Latin America, okay, here, Asia, Africa, started contributing to the global carbon dioxide emission much later. Okay, and Australia, okay, Africa, and the India, and Russia, and also China. So China's rapid growth in emission over the last few decades now make it the world's second largest cumulative emitter. So now China is the second largest emitter for the carbon dioxide, and it is continuing to contribute more and more carbon dioxide. So the key drawback of measuring the total national emission is that it takes no account of the nation's population size. So in the previous slides, these are the total the total carbon dioxide emission in the whole country, but it doesn't account for the number of population. So to make a fair comparison of the contributions, we have to therefore compare the emissions in terms of carbon dioxide emitted per person. So per capita means per person. Per capita emissions in most countries have continued to increase in line with the development. However, if we look at the current contribution of per capita emission, large global inequalities remain. So in this figure, this is the per capita emission. So most nations across the sub-Saharan Africa, the South Africa, the South Asia have per capita emissions below 5 tons per year. And this contrasts with the global north, where emissions were typically 5 tons per person, and North America have 15 tons per person. So let's look at the graph. So for the North America, the concentration will be around 15, okay, and also in Australia around 15, and these are per person, okay, per person carbon dioxide emission. And in the Arabia, the Middle East, the concentration is even higher. And how about China? The emissions per person in China would be around 2.5 to 5. Okay, 2.5 to 5 ton per year per person. How about in Hong Kong? Hong Kong is around 6 tons per person per year. So note that the carbon dioxide is not the only greenhouse gas which contributes to the climate change. So we still have the nitrous oxide and the methane, but they are not included in this graph. Okay, this graph is only for the carbon dioxide. And food production, especially intensive livestock rearing for the meat, for the dairy, is a major contributor to both of these non-carbon dioxide greenhouse gas. Since capita meat intake is strongly linked to the GDP levels, the gross development production levels, per capita emissions of nitrous oxide and methane tend to be much higher, much larger in the high-income nations. So when you are rich, you eat meat. So this is the trend. So many years ago, just so like in the days of my parents, they rarely eat meat. So maybe they only okay, so maybe they still can eat meat every day, but only a tiny amount. But now in the lunch or maybe even in the breakfast, you have a large piece of meat. And so eating meat or eating especially beef will result in the high carbon dioxide emissions. So these gases were included alongside carbon dioxide. Okay, so the global inequalities would be even higher. So when for the rich country, okay, for the rich country like the America, Australia, they are rich country and they eat more meat and therefore they also emit more carbon dioxide. But this whole earth are suffering from the global warming, from all kind of these climate change. So it's like in the Africa, okay, they are not contributing very much, okay, or the contribution to their carbon dioxide emission is very minor, but they are suffering. Maybe they suffer most from the global warming. Okay, per carbon dioxide emission per capita. Okay, so the year we are here, okay, we are here, and this is the beginning of the industrial revolutions. So the United States, this is the trend for the United States and the United Kingdom, okay, getting lower. They are doing a good job. And for Japan and China is rising. And for India, also rising. So what can we do? So for the countries, for country to countries, they have international treaty. So the UNFCC is the United Nations Framework Convention on Climate Change. So an international environmental treaty adopted in 1992. And the objective is to stabilize the greenhouse gas concentration in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. And the first treaty in the 1992 is legally non-binding. So there is no binding limit on the greenhouse gas emission for individual countries and contains no enforcement mechanism. So it is just like a voluntary action. So in this treaty, it includes it includes the countries in the North America, in Australia, and also Russia and Europe, and the countries in green color. Okay, these are they are developed country, so they should provide financial and technical support to the other countries. Okay, so this is the non-legally binding treaty. And then in the year 1997, the Kyoto Protocol was adopted, and it was established as a legally binding obligation for developed countries to reduce their greenhouse gas emission from the period 2008 to 2012. So this treaty is for this period of time. Okay, so based on the principle of common but differentiated responsibility, it acknowledged that individual countries have different capabilities in combating climate change. So for the developed countries, they have technology, they have the money to do more for combating the climate change. Okay, and therefore they put the application to reduce the current emissions on the developed countries on the basis that they are historically responsible for the current levels of the greenhouse gases in the atmosphere. So just like in the Europe, in the North America, so from long time ago, from 100 years ago, they started to contribute to the carbon dioxide emissions in the atmosphere. So they should take a greater responsibility to reduce the carbon dioxide emission. Okay, and we have the Paris Agreement in the year 2015. And China formally signed this agreement and put it into force from the year 2016. And the Paris Agreement applies to Hong Kong also. So the Paris Agreement came into force on the 4th of November in year 2016. So the long-term goal of the Paris Agreement is to keep the increase in the global average temperature to well below 2 degrees above the pre-industrial levels. So it is very difficult actually. So now the temperature has already increased by 0.5 degrees. Okay, so in reaction to the Paris Agreement, the Hong Kong government has published this this publication, which is the Hong Kong's Climate Action Plan 2030 plus. So it laid down some plan and some targets for reducing the carbon emissions. So you can search this document to take a look. Okay, the atmospheric carbon dioxide concentration. Okay, so year 2018, the concentration is higher than 400, so maybe around 420 ppm. And 100 years ago is just around 300 ppm. So now 450 ppm. So you can see the concentration has increased very much. And this is the change on the global mean temperature and its relation with the carbon dioxide concentration. So it is now around this concentration, 400 something, okay, so 400 something ppm, and it will increase the air temperature around, okay, the mean value around 1.5 to 2 degrees. So if the concentration continue to increase to maybe 100, then this is the range of the increase of air temperature. And if it increased dramatically to over 1,000, then the air temperature may increase by up to 8 degrees. So 8 degrees. Now the temperature 30 something and then increase 8 degrees, so maybe 40 something of the air temperature. Okay, how to assess the carbon footprint? It's now 9:25, so maybe we can take a break and then we can continue the slide maybe 5 minutes later.